So pay attention and study. So today we are going to do one sample t-test. We solved the first question yesterday. I'm going to solve a different question today. So one sample t-tests. You have been told by your lecturer, most of you, that's what you said your lecturer said the questions will fall on one sample t-test. Are you following?
Yes, sir. Yes, sir.
Joe, post in the group that we have started there.
Okay.
So
Please,
one sample
they're also
t-test.
asking. They're also asking which topics you are doing.
Oh, tell them I'm solving the t-test. One sample t-test. I'm not going to solve, I can't solve all the topics you want to do. I can't do that with you. I'm only doing the simplest ones. Let me put it that way. The simplest ones. So the simplest ones are the ones I will t-test regression. That one, 20 marks. Then go and fight over the other ones. Okay. So let's start. We have um, one thing we said was that for the one sample t-test, okay, it assumes mostly they would say like this word, it assumes a normality. Assumes a normality. When it says assumes a normality, it means that the data is continuous. Then we go back to what you did in level 100. Statistics. This is a normal distribution curve. What are the characteristics of a normal distribution curve? The mode, median, and mean are the same. They are located they are located at the center, right? The curve is continuous. The curve is the information flow. The information flow of the curve is continuous. So when it says it assumes normality, means that the data is smooth, is continuous. Basically that. And we also said that there are 5 steps in computing or in conducting a parametric test. So to conduct a parametric test, as far as the slides are concerned, there are 5 steps. The 5 steps is one, you would have to state the hypothesis. State the hypothesis. Hypothesis with an E. Hypothesis with an E is plural, meaning more than one. Hypothesis with an I is singular. So when you are stating the hypothesis, we'll be working with the H null hypothesis or the H naught. It is called null hypothesis. Here is an I because it's singular. Then we'll be working with the H1, which is called the alternative hypothesis. When you do your master's, you can have H1, H2, H3. You'll be testing different things. But here we are only limited to H1, alternative hypothesis. Null hypothesis, it is a phenomenon assumed to be true. Something assumed to be true, like a phenomenon assumed to be true. So a phenomenon, let's say, what is held to be true? What is held to be true or to be the case? Then the alternative is that same thing which is held to be the case or which is held to be the truth. Okay, which is held to be true, right? That same case which is held to be true, that case we will say that it is held not to be true. So not to be true. So for example, when I say a null hypothesis, I can say H naught. Kofi is a boy. Is it true Kofi is a boy? Okay. Then H1, alternative. I will not say Kofi is a girl. No. I will not say Kofi is a man. No. I will say Kofi is not a boy. In other words, the null hypothesis, the alternative hypothesis, is the negative form of the null. So the null is a positive statement, meaning that it is a positive statement, meaning there is no, what words do we use to signify a negative statement? We use the words no, not, never. Okay. So Kofi is a boy is a positive statement. To negate that statement, I say Kofi is not a boy, or Kofi is never a boy, or Kofi is no boy. So Kofi is not a boy. This is a negative statement. This is a positive statement. So to test the hypothesis you are testing is a null. Is it true Kofi is a boy? Is it true Kofi is not a boy? So that's the opposite. Okay. We'll be working with the averages. We'll be working with the averages. So H naught, we'll be working with a mean equals something. We'll be working with a mean is not equals something. Or null hypothesis, a mean is less than. Alternative hypothesis, a mean is more than. That's what we're going to work with. That is, so one, we state the hypothesis. Two, so I've explained what the hypothesis is. And we'll be given what is called significance level. Significance level, another name is called the alpha level. Alpha level. So let's say I have 100%. The survey I'm going to do, the research I'm going to do is it should be 100% accurate. And I'm giving a significance level. So when I'm giving a significance level, let me use SL for a significance level. It will pair with a confidence level. So if the significance level is 5%, 5% plus what will give me 100%? Who can tell me? Yes, 5%
95.
plus what will give me 100%?
95.
95.
95.
So the 95% here is called confidence level. So the question will always give us 5% significance level. If the question doesn't state it, you will still take it as 5%. It could be 1%, it could be 2%, it could be 3%, it could be 5%. So if the question doesn't state the significance level, you just take it as 5%. Are we good?
Yes, sir.
Step 2, we are going to look at what is called decision rule. We are going to find what is called a T-crit or T-critical or critical T. And the T-crit is made up of T degree, T alpha. If it's a two-tailed test, we'll divide it by 2. Then we'll find a degree of freedom. Then we'll go to the table and find the information on the table. The degree of freedom is equal to n minus 1. Mostly, let me put it that way. N represents the sample size. How many observations are we taking? Or the sample size. So we'll be looking at that. Then when we find it, we find a T-crit. Then when we find a T-crit, we will go and find what is called a T-cal or the T-stat. Then we compare the T-cal and T-stat against whether it is more or less than the T-crit. Then we make a decision. Number 3, we go with what is called computation. What are we going to compute? We are going to compute the T-cal or the T-stat. So the T-cal or the T-stat equals the average mean, sample mean, over minus the population mean, all over the standard deviation divided by the sample size. This is the formula we're going to use. Mostly in exams, they can give you the X bar, which is the average or the mean. They can give you the sample mean, they can give you the population mean, they can give you the standard deviation, and they can give you the N. So they'll give you the values for all these. They'll give you values for all these. So you just plug them into the formula. Mostly. Yesterday, the one we solved, there were no values given. So we have to go and find the values. T-cal. Then when we get the T-cal, we will take note of the T-cal finally. Then number 4, we will come and make a decision. The decision is the T-cal value we will get from 3. We will compare that T-cal value with the T-stat. And we'll make our decision. Then 5, we make a conclusion. The conclusion is based on the T-cal or the T-stats, we will reject HO and retain H1. Or we will reject H1 and retain HO. Are we good?
Yes, sir.
Yes, sir.
Then the conclusion, we will say at the level of, at the 5% significance level or at the 95% confidence level, we make a decision. That's all that we are going to solve. You do all this for 10 marks. Very easy. Is it difficult?
No.
Just these 5 steps. We have to master the steps. Next semester, depending on the area, you may use the same thing. So you use the same, this, you're going to use this next semester as well. So just pay attention. So this is what we are going to deal with. Are you ready? Should we start?
Yes.
Class, should we start?
Yes, sir.
Yes.
It's not difficult. It's practice. You are thinking of everything being difficult in life. Maybe nothing was made to be easy in life. So if some things are easy, that's fine. But some things are difficult. Some are even very, very difficult. So now let's start. I showed you just from a glance from per the slides how you can determine whether it's a one when we have tail tests, whether it's a 2-tail test or 1-tail test. So this example 9.1 is a 2-tail test. Why? The data fits simply. I can use another method, but let me show you the trick or the strategy. Simply, the data fills 2 rows. So it's a 2-tail test. And they are the same. Then this question, 9.2 is a 1-tail test. It fills only 1 row. I see they give the values here.
Yes, sir.
The next one is, this is also 1-tail test. Okay. Then this is also 1-tail test. This is also 1-tail test. This is also 2-tail test. Are you good? This is 1-tail test. Do you get it?
Yes, sir.
Yeah.
I'm not talking about the sample t-test. So I'm talking about we are dealing with one sample t-test. And one sample t-test, we can have 2-tail tests. When you say 2-tail test, look at the normal distribution diagram. I'm using red. The ends here are the tails. So this is a 2-tail test. We are talking about the two. So if it is 1-tail test, so it means that it's affecting only one side of the data. Are you getting it?
Yes, sir.
Yes, sir.
Any questions?
No, sir.
So yesterday, the one we solved, this is it. This is what we solved yesterday. These are the steps. So these steps guided me to solve it yesterday. These are the steps. So today we are going to use the same steps. These are the steps. These are the steps. So I'm going to follow. There are 5 per the slide. So I'm going to follow these 5 to finish it. So I'm going to start solving it. Okay, let's continue. Can you see my screen?
Yeah.
Yes, sir.
Okay, so now we know we have step 1, step 2. Let me circle the steps so I can see them all. This is step 1. This is step 2. This is step 3. This is step 4. This is step 5. Okay, let me pick another question. So you have to know all this before you get to the exam. So let me see. Follow the way I'm going to solve. So I'm going to solve 2 with you. Now, someone should read. Quick, 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 quick. Who is reading? Daniela Doku, read. Daniela, read.
Okay, sir.
Is it the Daniela I know?
No, sir.
What program are you reading?
Accounting and finance.
Oh, okay. So read.
Listed below is the annual rate of return, reported in percent, for a sample of 12 taxable mutual funds. And the table is 4.63, 4.15, 4.76, 4.70, 4.65, 4.52, 4.70, 5.06, 4.42, 4.51, 4.24, and 4.52. Using the 0.05 significance level, is it reasonable to conclude that the mean rate of return is more than 4.50%? Assume normality. The mean score and standard deviation were as follows: n equals 12, and the mean is 4.572, and standard deviation 0.241.
All right. So
Simonu,
let me put it.
Simonu,
Yeah.
please, I want to ask a question.
Okay.
So please, the mean rate, is it always given in percentage? Can they give it in like let's say in CDs, normal figure? Oh, okay. Okay.
One
Thank
thing
you.
about calculation courses or some courses, you have to solve different questions. And I'm deliberately solving the examples with you, though they have solutions, so that you can look at it carefully. Because sometimes they can lift the same this same example, they will change all the values. Are you getting it? Are
Yes,
you
sir.
getting it? In the exam, they
Yes,
can
sir.
bring example 9.2. They can bring the same figures. Or here they are 12. They can just cut 2 out and it will be left with 10. And they'll make the sample size 10. And they'll make the values here, the annual rate here 10. Are you getting it? Or they can leave the same thing and change, put a name there. So when I saw example 9.19 with you, its corresponding exercise is somewhere exercise. You see, this is an exercise. This exercise what? 9.2. Then the 9.2 example. This is a similar exercise of it. Are you getting it? So if we solve the 9.2 and you get this right, you should be able to solve exercise 9.2 because a similar example, they looked on that example and carved this exercise. So you should be able to solve the same thing. Are you good?
Yes, sir.
You should also be able to solve example 9.1. They looked on the figure and changed the figures and used 15. You'll be able to solve this. But I'm going to use the same approach. Are you good?
Yes, sir.
Yes, sir.
So that's how it is. But this one too, if you look at the way we solve the first one, a similar approach. So here, this will be 0. Here will be 0. The first one we solved yesterday. This is a similar exercise to it. So if you solve that one, you may be able to solve this. I get it because the one we solved was two-tailed. This is also two-tailed. So you should be able to get it done. Okay, so pay attention. The main concept is, or the main objective is to understand how to go with it. I get it. Though it has solution, that's how I'm displaying it. So pay attention. First, what are we asked to find? Using the significance level, 0.05 is the same as what? The percentage terms, what is it? In percentage terms, what
5%.
is it?
5%.
5%. So if this is the significance level, what's the other name for the significance level?
Alpha level.
Alpha
Alpha
level.
level. What is the confidence level?
95.
95.
95%. So that when you add both, you have what? 100.
100%.
100%.
Okay, so let's start. We'll start with the steps. Step 1. What is step 1?
State the hypothesis.
Still the hypothesis.
So the hypothesis, you write it, states the hypothesis. Let me show you to those who didn't say this. This step 1 states the hypothesis. So 1. So steps. 1 states the hypothesis. So we begin H naught. Now watch. Here it says that the mean rates of the return is more than 4.5. Is more than 4.5. So here we will say the null hypothesis is the mean is what? Less than 4.5%. Then the alternative, it says using the significance level, it is reasonable to conclude that the mean rate is more than 4.5. So alternative is what? Mean rate is more than what? 4.5. What are we testing? Let's see what they did. Are you getting it? So here too is another format they used. Look at this. They said it is. All right. It is. And here they said alternative. Alternative. I said alternative.
Yes.
Alternative is here. So here, what we are learning is that, hold on. Let me put it this way so I can get it. I could have used that method also. So it says, using the significance level, is it reasonable to conclude that the mean rate of return is more than 4.5? So that's what they just said. The mean rate is more than 4.5. It is the alternative. Is the new item they are bringing in. They are going to measure it against the now, which is, it is. Why is it this way? Now, the first one I wrote, mean is less than what? 4.5. If I said it is less than 4.5, if this is the now, the alternative will be what? It is not. Right?
Yes.
Right. But what is the alternative? The alternative says what? It is more than 4.5. The alternative says it is more. So if the alternative is saying it is more, this is an inequality. This is the alternative. Then the now will be what? It is.
Okay.
Are you getting it?
Yes, sir.
So the now says it is 4.5. Then the alternative is saying it is more than 4.5. So if it is more than 4.5, we will say it is 4.5. Then it is more than 4.5. Are you okay?
Yes, sir.
All right. Just master this. Now, whenever you have an inequality, mostly this is how, or this is what, this is approach to this one. Yesterday, we solved one which was involving it's S. So let me show you what we did yesterday. So look at what we did yesterday. It says what? What did the question say? Look at the question. The question says, I believe that the average income level, and we said average, what other word can we use for average? The mean. This is called population mean. We have the X bar. This is called a sample mean, your statistics. This is population mean. This is a sample mean. Average income level administration staff is significantly different from 1,500, meaning it is not 1,500. S. So if when you say something is equal to, when I say Kofi is a boy, I think I did the example here. You see, when we say Kofi is a boy, where is it? I wrote it somewhere here. I think I claimed it. let me write it here. When I say Kofi is a boy, if this is just in terms of grammar, if I want to write it mathematically, I'll say Kofi equals boy. Do you understand it?
Yes, yes.
So here it says the income level is significantly different from 1,500, meaning that it is not 1,500. That's the alternative. So here the alternative hypothesis will be the mean, the average is the mean. It's not. It said it is significantly different from 500. If it is significantly different from 1,500, it means it can be more than 1,500 or it can be less. Are we good? Are we good?
Yes,
Yes,
sir.
sir.
Then what will be the null? The null is always the opposite of the alternative. So if this one is the mean is not, then the null be the mean is 1,500. Do you get it?
Yes, sir.
That's what we did yesterday. Here. Are we good?
Yes, sir.
Yes, sir.
All right, let's move on. So that's step one. We are finished with step one. We'll finish soon. When we finish, then if you have any other questions, then we'll keep on. Now, and then we'll say at what's the significance level?
0.05.
0.0.
At, or you can say at 5% significance level. You can write 5% is correct. Then we go to step two. What is step two?
Decision.
Decision rule. Remember, I said this one is what? Two-tailed test. This very example is two-tailed test. But what you are currently solving, it is one-tailed test. And I'll show you how you can easily detect it. So we'll confirm from what they did. Okay. So decision rule is that we have to find the T crit. The T crit is made up of the T alpha level over, right? If it is one tail test, we will divide it by 1. Then comma the degree of freedom. Are you getting it?
Yes, sir.
Okay.
Good. And this is a one tail test, and I've showed you the technique. You should just know. Because most, let's say, this data can fill one side of the tail. The normal distribution curve, one side of the tail, this data can fill. The other one, they were two. The first row, second row. So they were two tilted. This is just one row. You can fill one side of the tail. Are you good? Let's see what they got.
Yes, sir.
They said it's what? One tail test. So if it is one tail test, then the alpha over 1. What is the alpha? The alpha is the significance level. What is it? 0.05 divided by 1. What do you have?
0.05.
Then you find the degree of freedom, DF. The formula for the degree of freedom is what? N minus 1.
N
What is
minus
the
1.
N? N is 12, right?
Yes.
Minus 1. What do you have? 11.
11.
11.
Let's see whether they got that. You see, they've gotten it here. Have you seen it?
Yes, sir.
Yes.
Yes, sir.
When you are done, you come to find your T crits equals, what is your alpha over 1? T 0.05, comma 11. From here, you go to your T distribution table. Statistics level 100 or statistics, you learn the use of the Z distribution, the Z distribution. Are you getting it?
Yes, sir.
Yeah, it's T distribution. So we go to the table and search for T 005 and 11. So somebody should send the T distribution table chart. So this is your T distribution table. With your T distribution table, the A here represents the alpha level. Here, this A represents what? Alpha level, right? And the V here is talking about, let's say, the degree of freedom. So like this, like this. Let's look at this one, for example. See here, look at what they did. Here, they put the T creds, they put in here the alpha and the 17 degree of freedom, and they got 2.110. So let's go and look at what it is. So T 0.025, which is 0.025, which is this 0.02. Oh, we don't have it
So
here.
that's it's at the next page.
Okay, 0.025 is here. And the T was what? 17. Look at the 17. Have you seen it?
Yes, sir.
Yes, sir.
So that's how come they got that value. That's how come they got that value. Here.
0.05.
So this is it here, the 2.110. So the same thing here, we have 0.05 and we need 11, degree of freedom of 11. So we go up 0.05,
There's also down.
0.05. Okay, it's here, 0.05. Don't wait till the last moment to you think, oh, let me do something, and you have no idea. 0.05 and what? 11. This is it.
Yes.
Have you all
So
seen it?
Yes, sir.
1.955.
So 1 point what?
Okay.
796.
1.796.
Yes.
What's in it?
Ah,
Let's continue. What is the third step? So we are done with this. So when you are finished with this, what did we say? At the point 3, when you are done with the when you are done, or when you are through with the T crits, what do you do next? You come and state this. You come and compare the T cal. You say, I'm comparing the T cal with the crits, whether it will be more or less. You make a decision. So we come here and say, if the absolute value of the T cal we are going to calculate is more than 1.796, reject. You first, when it is more than, you first reject the HO. Then you retain H1. Then you write the opposite side. We're going to turn this down. If the T cal, absolute value of T cal, is less than 1.796, reject. Here, what do you reject? What do you reject?
It's no.
H
The
not.
no.
H1.
Ah,
When it was
yes,
more
yes,
than,
yes.
when it was
H1.
more than, we are rejecting HO. When it is less than, we reject H1 and we retain what?
H not.
H naught, or the null hypothesis. That is the decision rule you have stated. So this 1.796 is the T crit. So we are going to find the T cal or the T statistic. So the step 3 is to what? Computation. Computation for what? The T statistic or the T cal. So I can go and compare.
Yeah.
That's one goes with the formula. That one goes with the formula T statistics or T cal equals the mean. You'll be given this form, you'll be given a formula sheet. So don't memorize the formula. Minus the U all over the sample standard deviation over the square root of n. And in this question, you see, they also got the same thing, right?
Yes.
Watch, they got the same thing, right? And this is their
Yes.
decision rule. This is their decision rule. Their DR. This is their decision, or these are their decision rules. I get it.
Yes, sir.
Okay. So computation, the formula sheet will bear this formula. The formula sheet will bear, so you can pick this from the formula sheet. You can pick this directly from the formula sheet. this. And the question had already given us the terms, the values for the items in the formula. This. They already calculated it for us. So I come into this formula sheet and I repeat, T stats equals, what is the X bar? 4.572 minus, what is the mean? What is the mean? 4.5, right?
Yes. Yes, sir.
4.5. So let's see what they used. They also used the 4.5. Have you seen it here?
Yes, sir.
4.5. So 4.5 over, what is the standard deviation? S.
0.24.
0.241 over the square root of, what is the n? 12. So when you are
12.
given a question, you must count all these items and ensure they are 12 as it is there. Are you good?
Yes.
Give me the numerator. What do you have for the numerator? Mm-hmm.
0.252. No, sir, wait, no. Hey. Let me see. 0.072. 0.072.
Divided by, now compute the denominator. Let me see.
Zero point zero six nine five. Wait,
You leave it in
oh,
three decimal places.
okay. 0.069.
0.069. When divided by this, what do you have?
1.035.
Is it the same as they got? Watch here. This. Is it the same?
Yeah.
It's the same.
No, but if you put in a calculator, it's different. Ha.
Oh, I've shown you how you should
Right.
do it. What are you doing again?
Yes, oh, it's true, but like when you put it in the calculator, it's different. When like you get
Put what in the
1.043.
calculator? Put what in the calculator?
When you put the 0.072 over 0.069 into the calculator,
What
it
do you
gives you
have?
1.043.
It's not, it's okay. So let's use 1.043. Don't copy what is there. Just tell me what it is. So let me write 1.043. 1 point what?
Oh,
Zero
sure.
four. It's a matter of the rounding. It's a rounding. Write what the calculator gives you.
Please, I'm sorry.
1 point.
Oh, don't worry.
Are you getting it? We are.
Yes.
It's because of the rounding. We've rounded the figures up. Okay, let's continue. But it's not wrong. It's correct. So now we've
So you
gotten the
get
T start. What?
so you get 1.0349. So if you round it to be 1.035.
But why are you guys giving me different figures? So it's 1.035. If you know, I've told you whenever you want to start with your calculator on computational thing, you want to use your calculator in exams, go to shifts and 9. Shifts and 9 and clear all errors. Joe, you don't do that. You go there and you'll be using different figures. Okay, let's go. So this is the T start we solve. The T start or the T cal, they are referring to the same thing. So you're having T cal, you're having T start here. Okay, let's go on. Now, what do we do? Step 4. What is step 4? It's very easy. Step 4 is what? Decision.
Decision.
Compare the T car with the T start. Compare the T car with the T start. Then it will tell you whether. So what? Let me explain it here. The decision rules we set here. We are now going to confirm whether or not what we obtain for the T start satisfies any of these two. This T start, does it satisfy any of these two? Whichever one is satisfied, that's what we are going to conclude on. So we will say decision. This decision will be guided by the decision rule in step 3. So we'll say that as the T starts is, what is the T start? 1.035.
Okay.
Is it more or less than 1.796?
It's less than
So as the T starts, so
1.7.
the decision rules, which one of them are we going for? Is it the first one or the second one?
The second one.
Because the T start is 1.035. Guys, are we okay?
Yes, sir.
So the two decision rules, right? Which one? Just look at the T car. What is our T car value? This is it. That value, is it less or more than the 1.796?
It's less than the 1.796.
Less
Okay.
than.
So we'll say as the T start is 1.035, less than, I'm copying the decision rule, the second one. Less than 1.796. What do we do?
We
Reject
reject H1.
H what?
1.
Reject H1 and retain what?
H not.
Or the null hypothesis, and retain H naught at the 5% significance level. Are you good? Then we go to
Yes,
step
sir.
Yes.
5. What is the step 5? Conclusion.
Conclusion.
What is the conclusion? We can say that at the, now watch. So between the H1 and the H naught, which one are we rejecting? Between the
Right.
H1 and H naught, which one are we rejecting?
The H1.
One.
So look at what the H1 is. H1 says what? It is more than 4.5%. And the H naught or the null hypothesis says what? It is 4.5%. So if we are rejecting H1, what will be our conclusion? So watch here. We will say this. Look at the way they place the words in the question. It says, using the 0.05 significance level, is it reasonable to conclude that the mean rate of return is more than 4.5%? Right? Is it reasonable to conclude that the mean rate of return is more than 4.5%? Is it reasonable to conclude, based on what you have just done, is it reasonable to conclude that the mean rate is more than 4.5%? Yes or no?
No. No.
No.
No. Because this mean rate is more than 4.5. It is the alternative, and he said we should reject the alternative and retain the what?
H.
And retain the null or the
H.
null hypothesis. So let's look at what they said about it, the conclusion. At the 0.05 level of significance or at the 5% level of significance, there is not enough evidence to conclude that the average annual rate of return is what? More than 5%. What I'm trying to say is that you just copy what they said in the question. Don't go and say at the 5% significance level, right? At the 5% significance level, here, you are picking from here. At the 5% significance level, it is reasonable to conclude that the mean rate is, or you can, or don't go and say that at the 5% signal level, right, the mean rate is 4.5%. Because we are rejecting the H1, doesn't mean you go and write it that way, that the mean rate is what? 4.5. No. From their own words, that's how you coin it for them. They want to know whether their let me say, their perception or their perspective here, which is it reasonable to conclude that the mean rate of return is more than 5%? That's alternative hypothesis. They want to know whether that is the case or it's not the case. So now that we finish with our work, that we have rejected their H1 and retained the H0, we can say at the 5% significance level, or we can say at the 95% confidence level, right? You can use either. At the significance level, right? We conclude, it is concluded that the mean rates of return is not more than what? 4.5. Don't write at the 5% second level, it is concluded that the mean rate is 4.5%. No, no, no. This is what they want to know as confirm whether or not it's true. We were testing the null to see whether the null is true against the backdrop of the alternative. So we can only make a choice in life when we have options. If I write only the null hypothesis, it's just one option. That is not a choice. That's what I have. So I just keep it like that. But I'll only make a choice when I have two or more. Then I will analyze both and choose one. And from our analysis, we are to reject the H1 and what? Retain the H0. So to retain the H0, their perception, their assumption, right? Their assumption or their hypothesis is what we will try to correct them that what you are saying is not the case. We will not say this is the case. We are trying to say that what you are saying is not the case. It doesn't also mean when you say that it is 45%, 4.5% is wrong. It's not wrong. But then you have to let them know their assumption is not what it is. Their assumption is that, or their perception or their contemplation is that, is it reasonable to conclude that the mean rate of return is more than 4.5? But from what we learned, which is their alternative hypothesis, from what we learned, their assumption, their phenomenon is not the case. So we would say the 5. At the 5% significance level, it is concluded that the mean rate of return is not more than 4.5%. So if it is not more than 4.5%, it could be the now, which we are retaining, which is what? It is what? 4.5. But we don't have to write this. We have to make them know the status of the assumption that it is not. It will either be it is or it is not. Are we okay?
Yes, sir.
Let's look at the one we solved yesterday. Yes.
So would there be a situation whereby you see the computation, I think the third step, can you get a negative after like to the third one?
Yeah, I can get a negative.
Can
When you
get
get a negative, figure, you can get a negative figure, yeah. When you get a negative figure, sometimes the mean here will be greater than this is the population mean, and it is called sample mean. Sometimes
yeah,
the population
the
mean
population mean
will
is
be
it the one
greater than.
inside say
I'm listening.
the population mean is it the one that you have highlighted as green?
Yes.
Inside okay.
Yeah. And the sample mean, why are we saying sample? Look at the description here. It says that, pay attention. It
Okay.
says, listed below is the annual rate of return for a sample of 12 taxable mutual funds. Are there only 12 mutual funds? No, there are so many, but they only took 12. So this data we are having here, which is called the average annual rate of return, is called a variable, right? They've only taken 12 out of the total. So sample is a sample is the portion of the whole. A sample is a portion of the whole, and the whole is the population, right? A sample is a portion of the whole, and the whole is a population. So you are taking a portion of the whole for your study, and that portion you are taking is called the sample. Are we good?
Yes, sir.
So and it says that using the 0.5 scenario, is it reasonable to conclude that the mean rate of return, mean rate of all returns, not these returns, not these returns, not these figures, of all the returns of the population, right? Is it reasonable to conclude that the mean rate of all the returns, right, is 4.5? So because they said the mean, which other word can they use instead of mean? They can use the word average. The mean is more than. So if they say mean is more than, what they've written here is grammar. They've written the theory, the grammar here, right? But the mean, this population mean, is more than 4.5. That's what we took to the hypothesis. And this one is the alternative hypothesis. Do you get it?
Yes, sir.
This is alternative hypothesis. So I picked it from the question. The mean rate, so they can use the word average, is more than 4.5%. Then this X is also another mean, but this one is a sample mean. This X here is a sample mean. How did they get this sample mean? It came from all these values. They added all the values from 4.163 plus this, 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 and divided all by 12. Right? They divided all by 12. When you divide all by 12, then you got this value. Are we good?
Okay. Yes, sir.
Now, so that's how they got the values here. Yesterday, the one we solved, let's look at something here. Here. It says, watch. It says, the average income level of university staff is significantly different from, meaning it's not exactly 1,500. So here the mean will be U. This is called the alternative. Always they'll give you the alternative. What their perception is. What they think it is. The U is what? One is not. Is significantly different from mean it is not. So the U is what? 1,500. And if we know the U, then this is the H1, the alternative. Then what is actually the case? That it is not. The opposites will be the alternate, the high, or null, or the H naught. The null is what? The U is 1,500. That's what we did yesterday. So watch. That's it here. The HO is, but first we have to know the null. We have to know the alternative. And based on alternative, we can state the null. And we will test to see which one is correct. When we ended, here it says the average. The average is the mean, population mean of administrative staffs. Here, all the administrative staff, not a portion. But when they were solving it, they sampled out 18 administrative staff of UPSA. UPSA, does it have only 18 administrative staff?
No.
No, more. But they only sampled out 18. So these figures are all sample data. They are sampled out of the total. The total is the population. But this average income is for all the staffs. Averagely, it's 1,500. So we use the population mean for this. Am I making sense?
Yes, sir.
So when we finished solving, we tested it. Here, they didn't give us the X bar and the N, so we have to do it ourselves. We have to do it ourselves. So when it came to the computation, look at the way we solve for the X bar. We added from 2,230 to 3,500. We added everything here. Here, we added everything and divided them by 18 administrative staff. We divided by the 18 administrative staff. Then we got 24,113. That's how I got the 24,113. We were in the formula, we're searching for values for the formula. So this is the X bar. We've gotten the X bar. Then we went to find the U. The U is already in the question. We picked it from there. We just did the hypothesis. Then the standard deviation too, we have to go and solve it. So how was the standard deviation solved? Each of the figures here, you square them. Each of the figures, you square them. So you square the 2,230, you square this, you square that, you square that, you square each of the sample data, the values, the random variables, you square them. You square this, you square this, you square all of them. When you square all, right, then you get the total for the x bar, x squared. So you square all,
So can
you
you
have
also
the
use
value.
the calculator?
Yeah, I'm going to use the calculator for everything. But just as if you use the calculator can give you the standard deviation, all right. It can give you this, but then you have to show working. So I'm talking about showing working.
Oh, okay.
You can use the calculator, use the X, and it will give you everything. But you have to show working. So how do you get the workings done? You must find, because they'll give you the formula for, it will give you the formula for the standard deviation in
Standard
the formula
deviation.
sheet. So you pick it,
Oh, okay.
go and show working before you conclude on this figure. Then the N is the sample size of this observation, which is 18. Then you come and plug them back into the formula here. This is the formula. You come and plug the values, all the values into the formula. Everything here. You come and plug them back in. When you plug them back in here, then we came here. Watch. We came to plug them back in here. Then we got the 4.2409. We found the T-stat. Then we have to go and compare the T-stat we've gotten with the T-car, with the T-crits here. The T-crits. This is the T-crits. These are the T-crits. We have to go and compare with the T-stats, whether it was more or less. But looking at our figure, we got 4.2. Was it more or less than the T-crits?
More.
It was more. Here, it's more than. So we have to choose this as our decision. We have two choices. We have to choose the first one as our decision, not the question we are solving at the moment. We chose the second option as our decision. But this one, the first one, is the first option. So we came and said, as the T-stats of 4.409 is more than the 201.1100, reject the HO. That was the decision here. If the T car or T-stat is more than 2.01, reject the HO, return the H1. So if it is more than, what do we do? We should reject the HO, retain the H1 at the 5% significance level. That's the final decision, because it is, then we said, at a confidence level of 95, yeah, I use confidence level. At a confidence level of 95%, or you can say at a 5% significance level, or at a significance level of 5%, there is enough evidence to conclude that the average, so this is what I was trying to hold, this is what they hold, this is what they believe to be true, this is what they believe against their norm. I get it. So we are going to see whether what they hold is true or false. That's all. So if he says that we should reject the HO, what he's saying is the HO says the U is exactly 1,500, whereas the H1 says the U is not 1,000. And that's what they are saying. They are saying the U is not 1,500. It's not 1,500 means it could be more, it could be less. But the H naught or the null hypothesis is stating that, claiming that the mean average is 1,500. So we said at a confidence level of 95%, based on a decision of 4, there is enough evidence to conclude that the average income level of UPSA administrative staff is significantly different from. So now we are confirming what they said, that what they are saying is true based on the test we've conducted. Are you getting it? Are we getting it?
Yeah.
But we are not going to write that based at a significance level, we will say what the student said is true. No. We are saying it is true in specific terms, right? So what they claim, their claim here is true based on our tests. That indeed the average income level of administrative staff in this university is significantly different from 1,500. That's what we just confirmed. We will not say that we have rejected the H naught is, we will not say it is not 1,500. We just quote what they said. Are you getting it? Hello, do you get it?
Well,
Have you guys gone to watch football?
no.
So here. Also, their claim is that it is more than 1,500. So is it true or false? Or prove it. confirm what they claim, confirm their claim or reject their claim. That's what we are trying to say. So he said at the 5% significance level, it is concluded that the mean rates, so I'm quoting what they said, but that's what I'm going to use to answer it. You can state it another way, but just for what the recommendations are here, let's stick to that. They said, is it reasonable to conclude that the mean rate of return is more than 4.5%? At the 5% significance level, it is concluded that the mean rate of return is not more than 4.5. So here their claim is rejected. Are you getting it? Hello, do we get it?
Yeah.